Hi, I'm Mathieu Kéan, the Graphics IP Domain Manager in TI's OMAP business unit. Today I'm here to talk about graphics performance in our next generation OMAP 5 processor. With gaming, streaming video, advanced user interfaces and stereoscopic 3Ds becoming more prevalent in smartphones and mobile devices, a mobile application processor's graphics abilities have never been more important. 2D graphics continue to play a role in supporting video rendering and display features. Our OMAP 5 processor includes a dedicated 2D graphics core as part of its high-performance, low-power design. This will allow the CPU and the GPU to be used for more appropriate applications at the same time 2D graphics are rendered, or even shut off to save power. We are also proud to work with Imagination Technologies to bring the most advanced graphics processing to our OMAP platforms to also accelerate 3D graphics. Imagination's PowerVR architecture is the indisputable leader in low-power mobile graphics, with over 70% market share. Let's hear from Tony Kingsmith, Imagination Technologies Vice President of Marketing, about what's important in graphics processors.
Responsiveness is the wow factor that users see and respond to in graphics-rich applications, whether it's a fast-moving game with cars screaming around tracks, or the smoothness of a user interface, or the maps flowing in a navigation system. These are the things that really will be the differentiators between the most successful applications using graphics and the rest of the pack. The success of Imagination's PowerVR technology has been built on two main pillars. Very high performance and extremely low power consumption. We make sure that every single clock cycle is delivering the maximum possible working performance, whilst the architecture makes sure that every cycle of performance is results that are going to be used in pixels on screen and nothing else. These two, when closely combined, enable us to deliver the efficiency whilst at high performance and very low power consumption that makes Imagination's PowerVR so strong and leading in the industry.
There are four things to consider when discussing graphics performance. Fill rate, measured in megapixels per second. Shader performance, measured in gigaflops. Polygon throughput, measured in triangles per second and mainly used in gaming applications. And SDRAM memory bandwidth, measured in gigabytes per second. Fill rate measures a GPU's capability to fill displays with pixels. And high fill rates are becoming more important for UI, gaming applications, and especially higher resolution displays. In fact, display resolution is driving the need for further improvement in fill rates. Shader performance also continues to grow in importance, as it defines the computing power of the graphics core, which is required to render realistic-looking scenes and support visual effects. More gigaflop means richer visuals and graphics, and the new OpenCL API will allow the OMAP 5 processor SGX544 graphics core to provide high-performance general-purpose computing capabilities, such as image or video post-processing, to offload the main ARM Cortex-A15 MP cores.
PowerVR architecture has been extremely successful because of a number of key reasons. One is that the architecture uses what's called a unified shader architecture, which means that the same engine is being used for both pixel processing and polygon processing, and it dynamically balances according to what is happening even within each individual frame of each scene. We complement that with our tile-based deferred rendering architecture, which enables us to make sure that the work that's being done on a tile-by-tile basis of the scene is all done on chip, which makes sure that we're minimizing the memory bandwidth required to get the maximum amount done. And the deferred rendering makes sure we only do the processing on those parts of the tile that really absolutely will result in pixels you see on the screen.
OMAP 5 processor will provide aggressive SGX544 MP graphics performance, supported by an advanced memory subsystem with memory bandwidth up to 8.5 gigabytes per second to address the strong demands for higher resolution and higher quality graphics in mobile devices. To put this in perspective, TI's OMAP 4 processor, which is now starting to appear in smartphones and tablets, performs significantly better than the competing processors. And OMAP 5 will be 5 times better than OMAP 4. This all adds up to much more advanced content and higher resolution displays for consumers. Imagine having a tablet that can display True HD, run rich user interfaces or browsing applications, and simultaneously display a console quality 3D game on an external 3D HD TV. Soon you will. The SGX544 graphics engine also supports Microsoft DirectX 9 graphics API, so OMAP 5 platform-based devices can run Microsoft Windows applications and benefit from the huge gaming portfolio available on the X9 API. And you can do all of this while maintaining a great battery life. OMAP 5 graphics subsystem leverage dynamic power switching and voltage frequency scaling power management techniques to provide several operating points for the multiple GPUs to dynamically optimize for performance and power.
Imagination is really excited to be working with TI on OMAP 5. It's the culmination for us of 4 generations of working together, bringing 2 great engineering teams to deliver the best possible result for the mobile and embedded industries. We're very excited by what OMAP 5 has to offer, and we're delighted that Imagination's Power VR is a key part of that success.
To learn more about the OMAP 5 platform, visit ti.com/OMAP 5. Thanks for watching.